Hey everyone, we're in the midst of a countdown. In just 18 days, 3IATLAS will be closer to Earth than it has been during the entire period we've been observing it. It will be more than twice as near as when Hubble took that iconic snapshot. With Hubble, James Webb, and all our major telescopes focused on it, we anticipate capturing unprecedented details. However, here lies the issue. Theoretically, 3IATLAS should be becoming less active as it distances itself from the Sun. It should be fading in brightness, and the coma ought to be shrinking. That's basic comet physics, right? But that's not the reality we're witnessing. The more we observe, the more anomalies emerge. Let's begin with what makes 3IATLAS genuinely remarkable, an anomaly that's extremely tough to explain, the anti-tail or anti-solar jets we've been observing. Check out this image. I've never seen a comet that resembles this before. The anti-tail is strikingly visible, extending toward the Sun for at least 1 million kilometers. Now, pay close attention. This isn't an optical illusion. True anti-tails only occur when Earth traverses a comet's orbital path. But, as evidenced by the trajectory, Earth will not intersect 3IATLAS's path at any point. This anti-tail is authentic, which should be physically impossible. To grasp just how strange this is, let me clarify the involved physics. The solar wind at 3IATLAS's position travels at roughly 400 kilometers per second, 1,000 times swifter than the thermal velocity of gas that is naturally emitted from a comet heated by the Sun. To put it in perspective, if you wanted natural outgassing to withstand this solar gale, it would be akin to attempting to walk at 5 kilometers per hour directly against a 5,000 kilometers per hour wind. Clearly, that's impossible. This is the reason natural cometary tails trail behind a comet, rather than extending in front. In the very rare instances where an anti-tail might endure against the solar wind, it typically gets obliterated within a few hundred kilometers, not a million. For the anti-tail to maintain its structure against such a powerful solar wind, its mass density must be at least 1 million times greater than that of the solar wind itself. Here comes the part that causes physicists' hair to stand on end. If the anti-tail indeed has this absurd density, then 3IATLAS must be losing mass at a remarkable rate of approximately 200 metric tons per second. Including the main tail in our calculations, the total mass loss in October and November reaches several billion tons, 10% of the minimum mass calculated for the object, which is 33 billion tons. However, here's the dilemma: NASA doesn't believe this object is that large. They maintain that the nucleus has to be significantly smaller. But if that's the case, the entire nucleus should have been destroyed by now. And there's more. Throughout the summer months, 3IATLAS exhibited no non-gravitational acceleration. It moved like a rock or like a ship under intelligent control. Then, around perihelion on October 29th, we detected measurable acceleration. For a natural comet, this would necessitate expelling over 10% of the object's total mass. We've already accounted for the 10% attributed to the tail. The math simply doesn't add up. Yet there's one explanation that resolves the equations perfectly: artificial propulsion. Chemical thrusters or ion propulsion would require much less mass since they have significantly higher escape velocities. Normal cometary outgassing moves at 400 meters per second, while chemical rocket engines exceed 4.5 kilometers per second, an entire order of magnitude higher. If we're discussing ion thrusters, this could reduce the necessary mass by up to 4 orders of magnitude. That aligns much better with the mathematics. And here's a troubling detail: this evidence has been submitted for peer review in several academic papers, yet no journal will publish it. Everyone simply dismisses it as if we're discussing fairies or ghosts. There are even more glaring contradictions. The jets are solid, columnar, and highly organized, created by an object that rotates every 16 hours. This should be utterly impossible. If the jets originated from multiple locations on the surface as the object rotates, they should diffuse, not appear as coherent beams. The only scenario in which a natural comet could produce something like this would be if there were a single location generating the jets, which would only activate when exposed to the Sun. But if this were the case, we would witness interruptions, like the beat of a heart. Instead, we observe orderly jets with no interruptions, as though they originated from an object that isn't rotating. Yet it is rotating, which brings us to another mystery. The brightness of 3IATLAS fluctuates by 10 to 20% with each rotation. According to NASA, the vast majority of the brightness is attributed to the coma, which doesn't rotate, rather than from the nucleus. If that were accurate, rotation shouldn't alter the object's brightness. However, in the images from astrophotographer Ray, you can clearly see a significant change in brightness and gas patterns as it rotates. This phenomenon shouldn't occur. A cometary nucleus lacks sufficient gravity to pull the coma along with it as it turns. Now, we must discuss another astonishing anomaly. 3IATLAS is set to intercept Jupiter at an absolutely prime location, the Hill radius. This is where Jupiter's gravity overcomes that of the Sun. It's a perfect spot for placing probes to monitor the planet or intercept its moons. We utilize these points ourselves for exploration. But something new has come to light that makes me question whether NASA might be attempting to obscure this anomaly. On October 30th, according to JPL, the non-gravitational acceleration was reported at 1.66 times 10 to the power of -6. By November 24th, this figure was reduced by a factor of 4. Avi highlighted that this positioned 3IATLAS nearly identical to Jupiter's Hill radius. Here's the unsettling part. I sent an email to NASA notifying them of this unlikely coincidence. They didn't respond, yet within days, they revised the acceleration again by a factor of 6. How could NASA have been so mistaken initially that it necessitated such a significant adjustment? And isn't it an interesting coincidence? They altered the figures right after Lowe mentioned this striking coincidence. Now the revised prediction places 3IATLAS just outside of Jupiter's Hill radius. Did NASA manipulate the data to avoid this embarrassing coincidence? As Lobo noted, the Vatican's insistence that Earth was at the solar system's center didn't affect Earth's orbit around the Sun. In the same manner, NASA's new models won't alter 3IATLAS's actual trajectory. We will discover the truth in the months ahead. Astrometric data from the Juno probe, ASRO, JUICE, and 16 Psyche will be vital in resolving this question. If 3IATLAS indeed passes within the Hill radius, defying NASA's adjusted prediction, numerous questions will surely arise. I'm not claiming that NASA is doing this deliberately, but it's a rather intriguing coincidence that just after LOE reported this anomaly, they refined the data, making the coincidence vanish. 3IATLAS continues to challenge our understanding of cometary physics. Each anomaly, the impossible antitail, the organized jets, the incongruous mathematics, and the Jupiter coincidence, all indicate something extraordinary. Whether it's a comet with extreme properties that could alter the textbooks on physics, or something even more fascinating that we are not prepared to accept, one thing is certain, we are witnessing something unprecedented. What are your thoughts? Are we facing extreme natural physics, or is something more at play that certain institutions would prefer to keep under wraps? The truth will come to light when 3IATLAS makes its closest approach in December and during its encounter with Jupiter in March. Share your theories in the comments. If you wish to stay updated on every development regarding a story that might shift our understanding of the universe, like, share, and subscribe. The universe is replete with mysteries, and we'll be here to unravel each one.